Hey everyone, welcome back to the channel. Today, we're diving into something every developer should know: design patterns. Whether you're just starting out or you've been coding for a while, these are essential for writing clean, efficient, and maintainable code. Think of design patterns like blueprints for solving common software design problems. They're not a specific piece of code you just plug in, but rather a template, a proven approach to solving a problem that you can adapt and implement in your own projects. We'll be covering some of the most popular design patterns, and by the end of this video, you'll have a solid understanding of how to apply them to your own code. Let's get started. So, what exactly are design patterns? Imagine you're building a house. You wouldn't just start laying bricks without a plan, right? You'd want a blueprint. Design patterns are like blueprints for your code. They provide a reusable solution to a commonly occurring problem in software design. They're not a specific language feature, but rather a way of structuring your code to make it more robust, flexible, and easier to maintain. You can think of them as time-tested best practices for solving specific design problems. Now, you might be wondering why you should even care about design patterns. Well, for starters, they make your code cleaner and easier to understand. When you use well-established patterns, other developers who are familiar with them can easily understand your code, making collaboration a breeze. Plus, using design patterns can make your code more reusable. Instead of reinventing the wheel every time you encounter a common problem, you can use a design pattern and save yourself time and effort. And trust me, as a developer, time is your most valuable asset. Let's kick things off with the singleton pattern. This one's all about control. Imagine you're building an app that needs to connect to a database. You don't want to create multiple connections every time you need to interact with the database, right? That would be inefficient and could even lead to problems. That's where the singleton pattern comes in. It ensures that a class has only one instance and provides a global point of access to it. Think of it like a vending machine. There's only one vending machine, and everyone interacts with that same machine to buy snacks. In our database example, the singleton pattern ensures that there's only one connection to the database, and any part of the application that needs to interact with the database can use that single connection. This not only makes your code more efficient, but also prevents potential conflicts that can arise from having multiple connections. One thing to keep in mind with the singleton pattern is that it can sometimes be overused. If you're not careful, you can end up with a singleton that does too much and becomes a god object, which can make your code harder to maintain. So use it wisely, just like your favorite hot sauce. A little goes a long way out. And next up, we have the factory method pattern. This one's all about creating objects without specifying the exact class of object that will be created. Sounds complicated? Let me break it down for you. Imagine you're building a game, and you need to create different types of enemies, like orcs, goblins, and dragons. Each enemy has its own unique properties and behaviors. Instead of creating each enemy object directly, you can use the factory method pattern to delegate the object creation to subclasses. You would define an interface for creating an enemy, and then each enemy type would have its own subclass that implements that interface. This way, you can easily add new enemy types without modifying the existing code. It's like having a magical enemy factory that handles all the object creation for you. The factory method pattern is particularly useful in frameworks where the exact type of object isn't known until runtime. For example, in a web framework, you might use a factory method to create different types of controllers based on the incoming request. This pattern promotes loose coupling, which means your code is less dependent on specific concrete classes, making it more flexible and easier to maintain in the long run. Now let's talk about the observer pattern.